So a Venn diagram is a bunch of circles in a box. Okay? And it's very useful for solving a lot of logic problems. Here is a very simple Venn diagram with one circle in one box. There are 100 students. 38 of them do archery. 62 hold targets. In this Venn diagram, the 38th circle represents the 38 people that do archery. Outside of that circle in the rectangle represents everybody else. The rectangle is a representation of the entire group. So the 38 plus the 62 equals the 100. The number in set A, if set A represented the students who do archery, is 38. The whole rectangle is everybody. If a student was chosen at random, what's the probability the student did archery? Well, you wouldn't have needed a Venn diagram to figure that out, okay, because it's so obvious. 38 out of 100. But we're going to get to some questions that things get a little bit more complicated. Good? Yes? So a couple of definitions. The complement of an event, and we're going to denote it with an A prime. You will also see it in a lot of textbooks with a bar over top. And it's the event that A does not occur. Okay? So if you wanted to say what's not A in the event above, it's all the shaded region of everybody who doesn't do archery. So if we wanted to figure out, well, what's the probability someone doesn't do archery? Well, that's the 62 people that are left out of the 100. Yes? Then you can get into different notations, and we'll look at notations because sometimes there might be 38 students do archery, 15 students do needlework. It's quite the school out of the 100, and there's 3 students that do needlework and archery, and then we're going to have to look how do we represent stuff like that. Now with the complement of something, because it's the exact opposite, an event plus its opposite is always 100%. Right? And so we can get into questions like, do you like pizza? It's either yes or no. And the opposite would, you don't like pizza. And if I ask the question, in this class, who either likes pizza or doesn't like pizza? Put up your hand. And so if you like pizza, you put up your hand. If you didn't like pizza, you put up your hand. And it should be that everybody puts up their hand, right? But sometimes those questions, and we're going to talk about the complicated definitions of and or for probability, okay? In probability, and means both at the same time. Do you like pizza and don't like pizza? No, because it's impossible to do both of those. Like and don't like pizza. Yeah, you could say, oh, but there's certain kinds of pizza I like and certain kinds that, okay, we're getting complicated here, right? Right? If I ask a question with or, you answer yes if it's one or another, right? And you can get really, if I ask, are you a boy or a girl, you have to say yes, even though one of them is your yes to one and not to the other, right? Do you like eating ice cream or, well, I don't want to be too disgusting, but something, rotten fish. There we go. That's pretty disgusting. But do you like eating ice cream or rotten fish? You would have to answer yes if you liked ice cream, even though you feel bad about the fact that you're kind of implying maybe you like eating rotten fish. But, so we're gonna get into those definitions of and or. Here is and. The intersections of events. And this symbol is and. You can kind of think of it as an A without the line across to help you remember. If something is and, if event A is ice cream and event B is rotten fish, this would be the people that like eating them both, perhaps as like a topping on your ice cream. Okay? So the intersection of the Venn diagram shows where someone is both in the A circle and the B circle. Suppose there are 100 students in a gym class, 38 do archery, and 30 play badminton. Of those, 16 do both archery and badminton. So now, based on this and just reading it quickly, if I say, how many people don't do either of those, it's not as easy to figure out. But if we draw our, can I make my archery 1A and my badminton 1B? Seems to make sense. There's going to be 16 right here in the middle that do both of those. How many people do only archery? No. How many people do only archery? They don't do badminton. 38 minus 16. So there's going to only be 22 in there. But can you still see in the entire archery circle still adds up to 38? How many people do only badminton? 14. But the entire badminton circle still adds up to 30. And if we add up all of those numbers so far, 14 plus 16 is 30 plus 22 is 52. That means there's only 48 students that do nothing. So find the probability that they do both. Well, the both is this section in the middle. And there's only 16 out of the 100 that do both of them. Find the probability that a student at random does not do badminton, but does archery. Okay? So this could be written like this. What is the probability that they're doing archery and not badminton? Sometimes you can visualize this by color coding things. So if I'm going to take this yellow out of here. I'm going to pick purple, make it thicker, and make it half transparent. How about that? Okay? So probability of archery and not badminton. Archery is A. So if I shade in all of A, that would be that section, right? Not badminton is everything outside of the badminton circle. So if I start shading everything outside of the badminton circle, and if my pen works how I want it to, you're going to see something amazing. Oh, so happy with myself. What do we notice? What part got shaded twice? The 22. Okay? So when we're talking about archery and not badminton, it needs to be in both of those. And so when I shaded all of archery and then I shaded all of badminton, there was one area that got shaded twice. And so our probability will be those 22 out of the 100. So with and, you're looking for where it's in both of those situations. Next definition, this symbol. This is a union symbol. In words, it means or. I remember it by pronouncing or with a weird accent, or. And it's kind of like a U, so then it's easy to remember. So if the and symbol is kind of like an A without the line, and the or symbol is like a U, and or starts with U, so easy to remember. Okay. So you've used the union symbol maybe with domain and range, right? When you had domains in two different sections and you were using interval notation, you had the union symbol, and it meant that the domain could be in this section or in another section. So when I say A or B, you could be in A, you could be in B, and you could be in both of them, right? So if I asked a question, do you like ice cream or Hawaiian pizza? You would say yes, because some of you like ice cream. So you would say yes to that. Some of you are lactose intolerant, can't eat ice cream, so you have to say no. Okay? But some of you like Hawaiian pizza, so you would say yes. And some of you like Hawaiian pizza and like ice cream. Okay? Maybe not at the same time or mixed together in a blender, but you would say yes to that as well. So we say yes if we like only one of them. We say yes if we like only the other one. And we would say yes if we would like both of them. And so with or, it's just shading everything and adding things up. Find the probability that a student does archery or badminton. If we go back here, that'll be the 22, the 16 plus the 14, which would be 52 people in total, or 52 out of 100. So how do Venn diagrams help us? Well, in logic problems like this, where you're not given all the information, you can use it to quickly understand what's going on. In a group of 30 students, so we draw a rectangle to show everybody. 17 play computer games. So if I make a circle for computer games, that circle in total will have 17. 10 play board games. So if I draw that circle, I like using different colors, not different pages. Black and blue. Blue for board games. And 10 people like board games, but I can't put any numbers in here yet because I don't know how many play both or like both. And I don't know how many are just computer games. All I know is that 9 do neither, so I can put a 9 out here. How do we use logic to figure out, say, well, there's a couple good ways to figure this out. So I want you to think about how you can fill in the rest of those 3 spaces. In the end, everything has to add up to 30 because there's 30 students. The black circle has to add up to 17. The blue circle has to add up to 10. Someone tell me what number they figured out next and how they figured it out. 6. So where would you put the 6? The 6 in the middle. So he's saying that he figured out the 6 next. How did you figure out the 6 next? Okay, these two together have to be 21. 10 plus 17 is 27, and it's supposed to add up to 21. Okay? So that means that because when you count this one and this one, you would count this one twice. And since you're over by 6, it must be 6 in the middle. Does that make sense what he did? You can also just add up everything. If I add up 17 plus 10 plus 9, I'm going to get 36. But if I add 17 plus 10 plus 9, I've added the middle section twice. So if I get 36 and it's supposed to add up to 30, that means that that middle section has to be 6. Perfect. Great strategy. Did anybody figure out a different number first? Did anybody figure out, say, this had to be 11 first? How could you figure out that has to be 11 as your first thing to calculate? So if I add up everything, I'm going to get 36. If I subtract 17, then I get 19. And if I make that, okay. How do we get that to be 11 if we want to find that first? And this is why I color-coded things. Well, but you're using the 6. Then you're using something else you found first. So that would work, right? You can find the 11 second easily if you knew the 6 first. Obviously, since if you knew the 6 first, you would then figure out that's 11 because it has to add up to 17, and this is 4 because it has to add up to 10. But I'm saying, how do we find the 11 first? Alan? 30 minus 9 minus the whole blue circle is 10, right? So this whole circle is 10 plus 9 is 19. What has to be left here? Has to be 11. Can you see you could have done that as well to figure out the blue number first to be 4. The entire black circle is 17 plus 9 is 26, making this 4. I personally like finding that middle number first. It's really easy to add everything up and recognize that we have that 6 twice. But it's good to see those other strategies as well. Yeah. Well, if I'm finding the 11 first, I know that this entire blue section is 10. If this is 10 and this is 9, that's 19. The only section I haven't counted is that 11. And it has to add up to 30. Okay? So it's the ability to think of this as a whole, even though you can't write 10 into that. Maybe it's easier to see if we took our eraser. Wow, that's a huge eraser, right? If I cut that line out, this is really easy to see that that's 10. But in your Venn diagram, you have this extra line here. So whichever one you find first, though, like if you find that 6 first, then the 11 is easy to find, and the 4 is easy to find after that. And once we have the Venn diagram, find the probability a student plays board games. Well, that you could have done without your Venn diagram. Plays computer games and board games, that one we needed our Venn diagram to figure out. Plays board games but not computer games, that one we needed our Venn diagram to figure out. So here's the Venn diagram for 2. Venn diagrams for 1 are really easy, 1 circle in a rectangle. Venn diagrams for 2 are fairly easy, 1 circle, 2 circles overlapped. Venn diagrams for 3 have to look like this. Venn diagrams for 4 can still be drawn symmetrical. Venn diagrams for 5 are, I think 5 is the first one that can't be drawn symmetrically. But Venn diagrams for 4, I think you have to move away from circles to do it symmetrically. Okay. Home economics class surveyed 1,100 students about which meals they ate in their dormitory cafeteria, and they found the following information. So you should be able to breakfast, lunch, and dinner, rectangle with everybody. Let's figure out what number we can put in here first. The middle one? How do you know the middle one? All 3 meals. So this one right here, I'll put a check mark beside it. That tells us that's 240. Perfect. It almost seems every time I see these questions, they put the one you can do first as the last piece of information. $275 ate breakfast and lunch. So that tells us that this one won't be $275. Because if it's breakfast and lunch, this has to be 35 because in between the green and the red has to add up to 275. You can ignore the blue, but between the green and the red, those 2 sections had to add up to 275. So now we've used up this one. Can you see you can also do this one? 505 ate lunch and dinner. That's between the green and the blue. So this number here plus 240 is 505. And same thing, 375 ate breakfast and dinner. That's between our red and our blue. So that adds up to 135. Now the first pieces of information, 425 ate breakfast. That means all the sections in the red circle have to add up to 425. So you do 425 minus 35 minus 240 minus 135, and we would get 15 in that section. Same thing. 680 ate lunch. All of these have to add up to 680 in the green. And 855 ate dinner. All of those would have to add up to 855. Now that we have all those numbers, there's 1,100 students. You'd subtract 1,100 off all those and 55. So figure out these probabilities.